Antonio with my co-host, Dr. Tony Ricci. If you're a first-time listener, hit the subscribe button, like the show. You can find us on YouTube and Spotify. Now, today our special guest is Dr. Omar Eldakar. We got some funny stuff to talk with Dr. Eldakar. He's an evolutionary biologist, and he's currently an associate professor in the Department of Biological Sciences, which is by far the biggest department on the Nova Southeastern University campus. It's like the gorilla of the campus. Dr. Eldakar earned his PhD from Binghamton University, which I looked up is the best public university in the Northeast. That's what they say.
Great school.
Of course.
Great
Oh, yeah.
school. Very ugly city, though.
Well, great school, ugly city, so it's a compromise. He also was a postdoc fellow. Get this, Tony. He was a postdoctoral fellow at the Center for Insect Science at University of Arizona. I think he got sick of the cold weather. He's like, get me out of here. I'm going to go to Arizona. He maintains a diverse research interest in adaptive behavior and physiology, ranging from sexual conflict in insects, cooperation and conflict in bacteria, contagious and spontaneous yawning. That stuff's kind of cool. And also human evolution and athletic performance. Now, before we get to the good doctor, I want to make a quick plug. The ISSN conference is June 15 to 17, Fort Lauderdale Beach. Register at issn.net. That is issn.net. So, hey, let's welcome Omar. Dr. Eldakar, how the hell are you?
I'm doing great. Glad to see you guys again.
Always good to have you. I'm always disturbing him with evolutionary biology questions, too.
I love it. I never mind.
Tony, I think one of the things that seems to be missing, and I don't know, maybe it's because sports science has become so specialized now that you don't hear people talking about the evolutionary basis for performance or evolutionary basis for why we eat what we eat, why we crave what we eat, why we go absolutely nuts if we're starving and we're willing to do crazy things like attack an animal that's 5 times larger than us. It just makes it easier to understand when you have, sort of the fundamental basis for behavior. And so that's why we invited Dr. Eldakar. So he's gonna edify us on this. Now, I don't know if we should start purely from explaining evolution, i.e. natural selection, or going into the winner-loser effect, which is super cool, which, hey, Tony, who just lost 2 straight fights in UFC? Heavyweight.
Here we go. I'm sorry, plugging something in.
Yeah. He lost
the 2?
Second straight fight in the heavyweight title. He was beat.
Yeah, well, my prediction on who was going to win it won it for sure.
Oh, Jones, yeah.
Yeah.
But no one predicted it would be that easy.
No, for sure not.
No.
Definitely, yeah.
So think of this. Cyril Gane, that was his second straight loss, which sort of ties into what Omar's going to tell us about. So I guess first explain to the layman, to the non-evolutionary biologist, evolution and why it's the basis for all biology, and then go into the winner-loser effect. Okay.
So evolution is just change over time, really. So evolution by natural selection is just a process that basically causes adaptive evolution or adaptive change. And the best way of really explaining it is using an example. So let's just say, we're probably going to talk about running at some point. So let's just say that you have a population and these individuals vary in their ability to run, right? So some are just stronger runners than others, some are weaker runners. Now those stronger runners are going to be more likely to get away from, say, a dangerous predator pursuing them, which reminds me, you saw that article, right? That was about the Park Service is saying don't push a slow friend over when you're running from a bear. And all I could think about is why not, but then I was like, well, it said it was a slower friend, so you don't need to push over a slower friend. They're already slower, so maybe they're just saying, hey, be more efficient and just keep running. Don't waste your time pushing this person. Or if they know that you're gonna push them over, then they should want to push you first. And then if you just keep following that logic, every time people see a bear, they just start fighting with each other. But anyway, you can imagine that that faster runners or stronger runners are going to be less likely to be captured by a predator. They also are more likely to acquire food, and then therefore have offspring, leave descendants. Now, let's just say that that ability to run better, maybe it's like because you have more efficient muscles, whatever. Let's say that that ability is conferred by a gene, a certain gene that these individuals have. And that gene allows them to be better runners, to then have them have more offspring who are also going to have that gene, compared to the alternative gene. So you could see that in successive generations, that gene should become more and more and more common. And you could imagine another mutation pops up, let's say, that maybe increases the length of the Achilles tendon. It makes a more efficient runner, a more effective runner. Well, then by virtue of that gene and that conferring that trait, those individuals are going to then, again, leave more descendants than individuals that have the other gene. So you'd imagine that the gene is going to become more and more and more common from just a very random beginning to now you have non-random sort of reproduction. And then that's basically the process. So it obviously is a very powerful framework to understand why things are the way they are. It explains many things even outside of biology, when you think of like why airplanes are better now, because the first airplanes weren't that effective. They're just falling right out of the sky, and you see all the different ways they tried to fly, all these different strategies that they used. And the ones that worked, that the traits that conferred an advantage in flight, those traits were differentially reproduced, by these engineers. And then you vary on that theme, and then you take the best of those variants, and then you vary again, and you take the best of those. And then now you have things like, these nice passenger planes and jumbo jets, and they're still going to get better because they're introducing new variation and new tinkering with things. And the ones that work or more effective are going to be differentially reproduced. So it's the same process. You're just really varying what's doing the selecting part of it, but it's a really intuitive and very simplistic process. But again, it really helps you understand why things are the way they are.
So just quick question, Omar, that would be a cool point on that, and not to go off topic, but I think it is kind of on it, because everybody likes to identify themselves with being the most evolutionarily fittest, or, particularly today. So in terms of when you say, just quickly in this analogy, someone might say, well, the best runner is Usain Bolt. Someone might say, no, it's a Roger Bannister-like runner, the miler, or some might say it's Kipchoge, the marathon runner. From just a pure survival perspective, and I know the whole thing isn't about running, but what are we calling a good runner? The miler, the sprinter, or the distance runner? I'm just curious on that.
Oh, no, it's a great point, and that's why I kind of left out. I was like, a stronger runner versus a weaker runner. It's deliberate there. Now I got to explain it. No. So the idea there was, we were adapted for endurance running, for having a relatively light body, running at a moderate pace, over pretty good distances, efficiently. So we're not really explosive, but you have to keep in mind that we're from a lineage of athletes. We're a primate, and all the other primates are just zooming around in trees, and that's pretty athletic to do that. You need explosive power. Right. I mean, they can outrun us easily. A chimpanzee can outrun you. I mean, easily, can easily overpower you, can easily climb faster. So that's really the foundation of like kind of how our bodies were, of these being these explosive sort of athletes. But later on, due to environmental changes and obviously selection, favored us to be endurance runners. I can get into that with much more detail if you like, but the idea is that really it favors us to be great endurance runners. So really any mutation to those genes that confer explosive athletes, anything that would maybe take down some explosiveness but make that more efficient instead, that gene will now be favored. But before, obviously, that would be selected against. But now that more endurance-oriented gene is going to be favored. So that's why most humans are actually, I'd say all humans are better endurance athletes than the classic mammal out there. But yes, of the human population right now, some are better at endurance and some are, again, better at speed. But even the speedsters that we have in our population, like Usain Bolt, yeah, he's fast for a human,
Right,
But he's not
right.
fast compared to like even like a house cat. He's not catching anything with that kind of speed, you know. And nothing against Usain Bolt, but
No,
he's
great
not going to catch
point.
anything with that speed. However, again, even though you think of him as a sprinter, he would be a much more efficient runner than any other quadruped that's out there, you
Got
know.
it. Yeah.
But compared to other humans, yes, he's a much more explosive athlete compared to all endurance. And that being said, so you can imagine again, like a lot of these explosive, you know, athletic genes were essentially being selected out in favor of more endurance genes. Because again, those explosive genes are really a liability over the long haul, over a great distances. So they're going to be selected against. However, before that genes were completely say or wiped out or replaced, I should say, then we invented more explosive hunting tactics like bows and arrows, and then now explosive and stuff like that can actually be very beneficial still in the environment.
Throwing,
So that's
right?
why they
Yeah.
exactly. So that's why they weren't like. There was a time at which obviously was a selection, very strong selection for greater and greater and greater efficiency and endurance, but ultimately, yeah, like it wasn't exclusively that way because we went away from the persistence hunting with more explosive strategies before essentially those genes were completely replaced. But you could obviously imagine that an athlete like say LeBron James, a fantastic contemporary athlete, when you have calories to, you know, give away
Exactly.
and stuff like that. But an athlete like him would not be the one you would want in your tribe necessarily for endurance, persistence hunting, because like this thing's got to eat, you know, twice as much as I do, and it's going to get tired and all this other stuff, you know. But you can that those traits can actually be adaptive in this modern environment, but they would probably be very strongly selected against in the ancestral environment.
Very cool.
Yeah. Now, I remember you talking about how there's a certain speed that humans can run or trot. I forget what the terminology is. That is just fast enough that if they maintain it, the herbivores, the four-legged animals, their top speed obviously is faster, but their ability to thermoregulate just isn't that good. So explain, and this dovetails into why we're endurance animals. Explain how that works again.
Yeah, so so to get at, we hunted using persistence, which has got to be terrifying if you're an animal. So when you really think about it, for almost everything that's out there, hunting other things or trying to get away from being hunted, it's all about explosiveness. You know, it's really a sprint, and the animal that wins that sprint either, you know, gets to survive or gets a meal. You know, it really depends on which side of the equation you're on. But really, it's just an explosive event. And you only have to just out, you know, athlete that other individual in a very short term. But obviously those things would be a liability over the long haul if you had to then have this, you know, do this for a longer period of time or cover a greater distance. But they never have to do that because nothing's chasing them over great distances. You know, it's always sprint. And then, you know, about 2.5, you know, whatever million years ago, all that changed, and we start running after these things. And all of this, all the selection before we showed up, all of that was favor them to be again more explosive, to get prey, to get away from prey. And now here we are, and we completely use that trait of theirs as a liability. And now because we're efficient, we're on two legs, so automatically we're more efficient. And again, we have a series of genetic mutations in our muscle, how we form a muscle. So we're in a more slow twitch versus high twitch, you know, that kind of balance. So ultimately it makes us really good at sort of not explosive to catch them right away, but as long as you can kind of see where they're going, they're going to get tired by the time that, you know, you're going to be able to catch up to them, and they're going to be tired. And then when you catch up to them again, they're going to act how they normally would act with every other predator that's out there and sprint away as fast as they can. And you can imagine if you were just doing a workout and you had a friend, you go, you just sprint off as fast as you can. I'm just going to start jogging. And when you get tired, go ahead and rest. I'll just keep coming to catch up to you, you know, and every time I catch up to you, you guys start sprinting again. They're going to be passed out before you even make it like a mile, and you'll be perfectly fine. So imagine that you're doing that to another animal that is really, really fast, but also not really, really good at all with endurance. And we can sweat over our whole body, so we can really cool down or using our whole body Most mammals can only sweat from their palms. They have to literally stop and pant to cool down to get that evaporative cooling. So we're jogging after these things. And again, their bodies have been shaped for just exploding away, exact opposite of what we're exposing them to. So they're going to just erupt away, and they're just falling right into our trap essentially. And we just simply out endurance them. It just becomes like a endurance game of chicken, where it's just like whoever passes out from heat exhaustion first dies. So yeah, anybody can imagine that any other animal that would be like us and be a moderate speed endurance thing, not really explosive at all, you might be also vulnerable to predation yourself. But we got big brains, we could throw things, we can have fire. So ultimately we can hunt using that strategy that everything else has as a liability. But at the same time, it's not a liability for us, because it doesn't put us in a bad way, because we can make up for it with having, again, like weaponry, and you could pelt an animal with rocks, a bunch of doom, 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 it's going to start running, no matter how big it is. So yeah, so that's basically why. Oh yeah, so getting to the running pace thing. So coincidentally, our efficient endurance running pace is just fast enough to force a quadruped, a four-legged animal, from going to a trot, which is not as bad for it, and to a gallop. A gallop, it's really jumping from front to back, front to back. A trot, it can kind of do that for a while, but it's just like you can only walk so fast, and you got to start jogging. And even if you're jogging really slow, you're still doing something different than when you were walking, a different gait. And you can see that with these quadrupeds, going from a trot to a gallop, even if it's only a little bit faster, even if it's a slow gallop, it's still much more costly than a trot. And our endurance, our comfortable endurance running pace of humans is just fast enough to force these African quadrupeds to go from their trot to their most inefficient form of locomotion. So we basically just brutalize these things. Again, they're getting hot, they're getting tired, and they're just, you can't outrun exhaustion. You just can't do it. That's the one thing you can't outrun, is getting exhausted. So you can imagine that we were extraordinarily successful in this strategy. And we'd pick the big animal. You're not like a lion, you go after the sick or the weak one. You go the big one right there with those big old horns. That one.
More meat, more fat, right? I mean,
it's gonna get tired carrying these big horns running around.
And again, you get more from it.
Yeah, but in every other walk of life for that animal, being bigger was better. But only when humans show up is the biggest individual now the most disadvantaged. So again, you just blast it with a few rocks, and it just goes, and it starts running away, and then it runs to its doom, and it just passes out from heat. It might just pass out dead. And all you gotta do is make some tools and dress the animal right there, and you got food. So
how terrifying is that? You're being chased, and the chaser just won't get tired.
Yeah, I mean, just imagine that. It's like at least you get the quick death if a lion's going after you. It's gonna just and just get you and just choke you out, and that's the end of that. But getting pursued to exhaustion, I imagine that's just like it's like being in like a plane crash where you're just like, oh, the plane's going down. I mean, we're gonna die in a few minutes. Like it's gonna happen in the distance. It's not just like you got surprised by it, So I imagine it's pretty it's pretty horrible situation to be in.
No, this is fascinating stuff. I've always loved evolution, and it's one of my favorite classes as when I was an undergrad bio major. I have like 500 questions, Tony. So if you have any to ask away, because I have a whole list.
Okay, so no, I'll conclude the entire day and let Dr. A go at it, just with a comment elaborating on it to Dr. Antonio's original point. Is people take everything into context of modern availability, right? Like, so what I mean by that is, oh, no way, if you're a linebacker in American football, you're going to be able to rip everybody off, everybody's head off 10,000 years ago. Yeah, but that guy sleeps, that guy's got protein shakes, that guy's got a physical therapist, that guy, none of this is available in the early days. This is why, to your point, energy utilization is really important, and energy intake is really important, because the inherent assumption today is that everything was then the way it is now. And so this is where I think the problem we have. People fight today in the United States. Well, you're supposed to be vegan. You're supposed to be omnivore. Yeah, because we have that luxury. 10,000 years ago, the Dakota Indian tribes, or the Sioux in the Dakota Plains didn't say, it's 10 below zero out and a buffalo is running by, but we're vegan right now. So my point is, this is so cool, Omar, because to Dr. A's point, and I'll let him take it from here, we compare our resources today, right, to what was going on then, and say the bigger, stronger guy today is going to be the survivor of back then. But that isn't the case, because to your point, LeBron's going to need more energy. He ain't ordering it in from DoorDash, and he's not going to Publix to get it. So it's a whole different world back then.
Yeah, I mean, and exactly. We're adapted for an environment of scarcity, not an environment where you're overloaded with resources. So you simply couldn't generate the athlete back then. It's the same genes, by the way, but it's just going to manifest a different individually entirely. I mean, just think about the gene that people will blame for, like, say, getting type 2 diabetes. A gene that has you produce less insulin, or be more resistant to insulin. That gene, that makes you more thrifty. You're able to survive with fewer calories and fewer resources. Your body is just sipping every little thing coming into it. It's using every calorie. It is so thrifty that famine, anything, that body is much more likely to survive those conditions. But now you instead reverse the situation. You have an extraordinary amount of calories and access to calories. Now that gene that is very thrifty, with your metabolism, is now going to make you much more prone to obesity and metabolic metabolic disorder, and cardiovascular disease and all sorts of things. When that same gene literally was positively selected for because it was helpful to humans, that same exact gene could be completely selected against, or it's completely mismatched, I guess, with this modern environment. And again, you could think of, a gene that might make you able to process calories and just build muscle on top of muscle on top of muscle. That gene would be very disadvantageous ancestry, which is probably why it's not super common now with a lot of these individuals. But yeah, it just you make a great point of saying that, like, think of exercise. An animal that goes, what, I'm just gonna get up and burn calories. That would be the worst decision the animal ever did, is just burn calories arbitrarily.
Wait. So are you saying that my house cats, they're so evolutionarily advanced that when they sleep all day, that's actually the correct thing, right?
Yeah, I mean, if you are lazy and you don't want to get up and really do much, that is actually it's adaptive. I mean, to a point, but it's adaptive. If your body's like, hey, there's food right here, why else would I burn calories? I already got it right here. Like, why? I might need this fat for later, and that's how your body's basically acting. And ultimately, you'd imagine that burning calories arbitrarily would be completely selected against, because evolutionarily we were exposed to recurrent situations of not enough calories, never too many calories.
Exactly.
So all the adaptations are going to be on how do we survive with as little as possible, not how do we survive with essentially as much as possible. And that's why, you see this animal might just be fat and obese and just keeps eating and keeps eating. What is this thing doing? And you just go, it's behaving adaptively in a different context. It's not adaptive right now, but that would have been very adaptive before, So it is wild to think that something like exercise would be wildly unadaptive or maladaptive before, but now you need it to actually survive in this contemporary environment. So it's just such it's such an odd thing.
Now I have a slight sidebar story. I had a student send me a TikTok video. They said, hey, by the way, you're on TikTok. Well, you aren't on TikTok, but there's people criticizing you on TikTok for something you said in an interview. And this is what I said. And I want you to explain the evolutionary basis for this. I said, it is very difficult and disadvantageous for you to put on a lot of muscle mass. Number one. Number two, we are programmed, I mean, not in the computer science sense, but we are programmed to put on fat mass. That's why training to gain muscle is extraordinarily difficult. You know, they didn't have PEDs 10,000 years ago or whatever.
Yeah.
And that's why it's so easy for us to get fat. And they're like, well, no wonder some skinny scientists would say that I can put on beef, you know, just give me a lot of protein shakes, give me some PEDs, you know, and lift heavy weights. And I'm like, no, that's not what I meant. That's not what I meant.
Yeah. You got cold ropes for that, by the way. You did, actually. He did. He got criticized. Yeah.
Yeah, it's wild because I mean it's hard. I mean, I teach a class on or a whole course on human evolution, and it's very, a lot of these topics are very taboo, you know, like obesity and stuff like that, because it's something that's extremely important, and it makes sense evolutionarily, you know, from a perspective to think this way, but it's very uncomfortable for people to talk about, you know, and it's because it's very easy to become obese. It's very difficult to exercise and stay in shape because everything in your environment is right now is basically helping you not be in shape.
Exactly.
It's giving you access to all the fat and all the meat you could ever need without having to lift a finger for it. Well, a credit card. We have to really do much to get access to that meat. And again, we're obviously selected to not be exercising and burn extra calories and basically be as lazy as possible. So you put that animal in this modern environment with calories everywhere and like, then of course, again, you're going to be disincentivized your body to exercise, and you're going to be really incentivized to eat, you know, a high calorie diet and get as much calories as you possibly can, because again, ancestrally, your adaptations are to help you survive in an environment where there's not enough calories out there. You need to work really hard to get those calories. So ultimately, yeah. So the idea of these massive athletes, you know, they can gain a lot of muscle. It's very difficult. It is very difficult to gain a lot of muscle mass because again, your body it does not really want to hang on to it. A large body just has more maintenance costs. Its basal metabolism has to be higher, and that's why if you could take a athlete just gets big and strong, and you go stop going to the gym for like a week, and they'll already start suffering losses because their body's like, I don't need this. Get it out of here right away. Like right. The only way you can maintain that is by you essentially showing your body, hey, I'm living in an environment where I have to keep doing this all the time. Right. So you better build the muscle to accommodate that. But we have the calories to do it. So cool. But the minute you're not in that environment anymore, your body goes, I don't need this costly muscle anymore, and just loses it. And again, fat is more the opposite. Your body's saying, you know, we're in a calorie depraved environment. So we should always, again, try to eat as many calories as possible. Therefore, you're always going to have these cravings and desire to just eat calorie-rich foods, and that's going to lead you to fat. And again, nowadays, there's such a thing as being too fat. Ancestrally, it just didn't happen. An individual is like, all the adaptations are, oh, you don't have enough fat, right. And now you're not going to have your period. If you're a female, you're not going to be, say, fertile because you don't have enough fat. There are no adaptations where, hey, now you have too much fat, so I guess you're going to be extra fertile. No, you just now are producing way too much estrogen, and your, you know, risk of getting breast cancer, you know, are elevated, and another reproductive cancer. So really, it just has to do with what we're evolved for versus what we're currently living in, and that is why evolution, an evolutionary perspective, is so important to understand even things like health. It's not just for answering like some behavioral questions and fun stuff, but it really does help you put things like diabetes into context, you know, obesity into context, you know, helps you really understand these types of things.
I saw just a quick, a funny sign outside a restaurant, and this is the case for me, that said, I wish everything was as easy as getting fat. We're pretty good at it in this modern day, but to your point, there's no inhibiting mechanisms. People go to 500, 600 pounds, whereas naturally, without taking 3 grams of drugs a day for body, you know, muscle, everybody's going to have a genetic limit on that, right? But unfortunately, with the weight gain, we have people, sure, some die before 800 pounds, but some actually make it to that weight in pure adipose.
Yeah, and you have to think that you got to think of what was a greater chance of killing you, having too little calories or having too many calories. And again, you could just simply think that ancestrally, there was no incentive to not eat everything you possibly can and as much of it as you possibly can. There's literally no disincentive for that. Everything was the opposite. Eat as much as you possibly can because you might not find food for a while. So there was always incentive to overeat because the potential of overeating never existed. There was never there was zero selection for restraint. And you can obviously see that's why an individual can just power down some fast food and quite literally their body is hungry like an hour later going, get more of that, because it experienced those high quality calories, that dense calorie food you just ate, and it goes, do that again. And that's why, if you ever noticed, if you eat, say, breakfast in the morning, you eat like a big old bowl of sugary cereal, you're starving at lunchtime. You're absolutely starving at lunchtime. If you didn't even eat anything in the morning, you're going to be hungry at lunchtime, but you're not going to be that starving.
You're right.
Because your body just goes, I just got this sugar, and it burned that sugar, and it goes, I don't want to go into the fat. You showed me you can get me sugar, get me more of that sugar. I'm not trying to tap into these reserves. You just showed me you can do that. But if you woke up and you didn't eat any food, it doesn't have the option. It just starts burning the glycogen and then burns into the fat. And that's kind of the premise of the sort of the keto diet notion. But yeah, you can really see how your body is just, it's really easy to get fat, because ultimately, again, that was the goal ancestrally, was to try to have enough food that you could possibly get fat. You'll just never get there.
You can survive the winter famine. Maybe this is more of a speculative question, because I follow a few physicians and physician groups that talk about obesity. Now, someone piped in, and it wasn't a physician. I think it was actually a biologist who said, you can't treat obesity as a disease because it's actually an evolutionary adaptation. Putting on adipose tissue, whether it's 10 pounds of it or 100 pounds of it, is actually an adaptive response. So I don't know if there's a right or wrong answer to it, but how would you view it, since you're coming from the lens of evolution versus, I think a lot of medical societies want to classify it as a disease when in fact it's just an outgrowth of evolution.
Well, I guess what I'd say, it's a mismatched disease is what we would consider it. It's a disease in the sense of, obviously it's harming the body, but it's a result of an adaptation for a different environment in this now mismatched in this contemporary environment. So when you think of something like that, when you try to contextualize something like obesity, it is kind of mind-blowing, because you're going, the genes aren't the problem here. The environment is the problem. These genes are, we're the descendants of the best endurance running athletes, the ones that were the best at, storing fat and all these things. Like, we didn't evolve from, slouches that were just terrible at what they were doing. These genes are fantastic genes that we have, I mean, for the most part, but ultimately it's this, they're colliding with this contemporary environment. So it's obesity is just a symptom or a side effect of being an organism adapted for one environment and now living in this environment that has excessive calories. So you can't stop that. You can't solve that problem unless you address the environment. It's the same idea, like, think of cavities, right? We have a bad diet with sugars. How were hunter-gatherers not getting plagued with cavities and having their teeth rot out of their face and dying, when they were young? Like, how do they cope with that? Easy. They didn't eat as many sugars and stuff as we did, so they weren't vulnerable to it. But we can just brush our teeth before we go to sleep. So that the negative consequences of eating those high sugary diets and stuff like that, and the starchy stuff that gets all stuck in it, we don't suffer a lot of the health consequences, because we can just go to the dentist and we can just brush our teeth and we can clean that up this way. So we can perpetuate this bad environment and these bad behaviors. We can perpetuate this bad diet. And then what happens, individuals also, get obese. And what do we do there? We have different, pills and medications and treatments, and everyone has to go to the gym and exercise, to try to cope with it, because it's a product of our modern environment is we just have so many calories in it. So it's some of those, it's one of those things where you go, it's not, we're evolved for a different situation. You put us in this modern environment, we're gonna get fat. I mean, we're evolved to eat as much as when people are going to go on the paleo diet, you go, the paleo diet is quite literally eat everything you possibly can get your hands on, and as much of that as you possibly get your hands on. And and prioritize the high calorie thing.
Exactly.
That's the paleo diet. Get as fat as possible, because ultimately, again, we had to, that's why, your cat that's not running around is on the paleo diet. Look what happened to that, look what happened, it gets obese over time. So yeah, it's a bad thing.
So what you're saying is the Liver King eating testicles and lifting weights and getting a suntan, that's really not paleo. Is that what you're saying?
Yeah, but also wasn't he just like taking a bunch of steroids too?
Well,
of course.
Yeah, not the way to go. But I mean, again, like it was very adaptive to want to eat meat and fat, because there's more calories in meat and fat than there are, say, vegetables. So if you had limited time, limited resources to go after food, then you should prioritize the things that are going to get you more calories per capita. So fundamentally, you should crave things like fat and protein, because it was more calories in it, and it's also really difficult to acquire. You have to get meat from an animal, and I don't know about you guys, from what I hear, they're notoriously disagreeable with giving up their bodies for, selfish. So ultimately, you need these cravings to motivate you to make that decision, to go after this, to better use your time, and to pursue these more difficult, calories to acquire. But nowadays, though, again, so these cravings for meat and fat were probably so strongly selected for. It's why we have these incessant cravings for it. Yet now in this modern environment, the meat's the same price sometimes as vegetables, and it's just one aisle over or one shelf different in your refrigerator. So the brain that's evolved for making decisions in a completely different environment would make you make good decisions back then. It's going to make you make terrible decisions right now. If you ever walk to your fridge, your choice should always be bacon and butter and fat, and it should never be, I'm going to make a salad. That's a lot of willpower to then. I guess I'll eat a salad. That's a lot of willpower to make that decision.
And you're going to live a week 10,000 years ago if that's all you're eating.
yeah, exactly. So you can see that it's all of these things like, obesity and this and that, and the disease that, people are venting about and very uncomfortable with and complaining about. It's just simply a collision of our ancestral bodies colliding with this contemporary environment. And this is just a fallout from that. And it's very uncomfortable, because what do you want to go back to being a hunter-gatherer? I don't.
No.
I like living in air conditioning and, walking to said refrigerator and grabbing the meats. I like that. So it's really an uncomfortable. What do you do about it? It's just like, how do you solve all these global problems? You get rid of like 80% of the population. That's okay. How are you going to do that?
Yeah, are you familiar with the data on the Pima Indians? How I think rates of obesity and diabetes might be the highest, I think, in North America. I don't know, Tony, if I haven't looked at any recent papers, but a lot of it must stem from the fact that they basically subsisted, just like a lot of Indian tribes in North America did. And then they basically introduced to this sort of excess of food. It's like, now modern day society. And maybe it wasn't Pima Indians, maybe it was the Aborigines. You brought up that example that, hey, what if you just go back to the original Aboriginal way of life? What happens? And so
it was an Aboriginal group in Australia, and they're very vulnerable to developing type 2 diabetes when they integrate into the contemporary society of Australia. So what happens is they convinced 10 males that developed type 2 diabetes after they left the Aboriginal lifestyle and went to the contemporary lifestyle. They convinced them to go back to the Aboriginal lifestyle. And basically their symptoms were alleviated. Their body fat went down, and so type 2 diabetes is typically brought upon because, so insulin tells your body to store. It tells your body to take the sugar and the fat out of the bloodstream and put it into the cells. So if you already have a lot of fat on you, your cells are going, no thanks, we got plenty of fat and sugar. So it becomes more resistant to the signal of insulin. So you have to produce more insulin now to get the same effect. And then obviously those cells become fatigued. So lowering fat will reduce that resistance, make you more, what do you call it? The opposite of resistant, more
sensitive,
energized, sensitive. There it goes.
Yeah.
More sensitized to insulin. And also physical activity will also increase that the sensitivity to it. So really by having these individuals go back to the hunter-gatherer lifestyle, they were essentially just going back to the environment that their body's actually adapted for, a calorie restricted sort of situation that requires a tremendous amount of endurance oriented sort of tasks. And ultimately their body fat went down, mostly the liver, sensitivity of the liver to insulin improved. And yeah, they were basically alleviated of type 2 diabetes. I mean, there's plenty of studies out there that show, one in particular that had pre-diabetics. They had, it was a lot of images in this study. They had a few thousand of them lose, I believe, 7% of their body mass. Another few thousand take the most common the type 2 diabetes drug, metformin. And another couple thousand or a few thousand individuals just do nothing. They're the control group. And the ones that were least likely to develop type 2 diabetes were the ones that lost 7% of their body weight, of their body mass. It's because they just simply changed their environment. They changed their behavior. Individuals that took the pill, metformin, they just continued on again with these mismatched behaviors. And then they're ultimately going to get that mismatched disease. So it really shows that it's just type 2. I mean, hey, we don't have people aren't dying from polio and smallpox and stuff, and the flu's not ripping through the population and wiping out 50 million people. We have those things we can be happy about with modernization, but at the same time, we have some modern diseases like obesity and allergies and stuff like that.
Hey, Omar, if you don't mind shifting gears, 2 more topics before you got to go.
Right.
One of these I know nothing about, but Tony, I thought it was interesting that the physiology of yawning, somehow it cools your brain. Is that what it does?
Yeah. So yawning, the yawning literature, this is, it was originally discovered, the function of yawning, spontaneous yawning, by a good friend and collaborator, Andrew Gallup. You guys met Andy.
We met Andrew.
So he discovered why we yawn when he was an undergraduate, and obviously pursues this studying this line of research. So I would join him on a few projects and have a couple going. So to explain what the function of yawning or the physiological effect of yawning. So yawning, remember, it's a deep inhalation of air. So you're bringing this air into your lungs. There you go. And that air in your lungs is going to cool the blood that's right around your lungs. And now the powerful stretching and flexing of your jaw muscles, it squeezes blood out. So that's how your blood gets away from your heart, from the power of the heart pumping it, but it gets returned to the heart by your muscles moving and squeezing that blood back to the heart. So when you're yawning, you're kind of forcing this hyperthermic, this hot blood out of your head, face, and neck, out of this area. But you're also introducing that cooler blood that just got cooled by the air you just took into your lungs. That blood is now going to be introduced to take its place in your head, face, and neck area. So that ultimately you're just ushering out warm blood and replacing it with cool blood. So that's why if it's over your body temperature outside, individuals are less likely to yawn, because it would be counterproductive, would actually increase your brain temperature. So really it's about increasing circulation, but you're typically introducing cooler blood, and that then allows you to essentially be more vigilant, more aware. That's why you yawn, but when if you're about to fall asleep, people notice you yawn. And the yawning is actually it's them fighting falling asleep. Because they're falling as they're getting sleepier, their body temperature is actually increasing, and you're fighting against that to stay awake. So when someone's yawning, they're actually antagonizing sleep.
Thank God I don't teach 8 a.m. classes, because I saw a
And
lot
you
of
yawn,
that.
yep, and you yawn in the morning as well, because again, your body is trying to antagonize it, antagonize sleeping. So there's also, I mean, a good reason why it's contagious, because if you're just sitting there and you're looking out for predators and whatever, and your buddy is over next to you looking out for predators too, and then you see them start yawning, you're like, wait a second, maybe they're not paying as good as attention as they maybe should be. Maybe they're less vigilant. So that should, for one, spur you to yawn, because that will obviously increase your vigilance. If you were having any kind of drag, you're going to revive out of it. But it's also essentially a cue. You're seeing that they're not vigilant, so you need to pay more attention now yourself. So that's really why they're not signaling to you that they're tired and whatever. They just are tired and whatever. But you're seeing that, and because you're seeing that, now you're more likely to be like, I need to wake myself up and then be more vigilant. So that's part of the contagion effect.
Okay, last topic, and Tony, you're going to love this topic. I want you to pipe in because you have real world experience with a lot of top-notch athletes. The winner-loser effect. First, explain when animals fight, you can almost predict the winner and loser, and then use that, and then you followed up with data on baseball, I guess baseball and softball, and then I wanted to dovetail into the fight sports because I feel like we see the same thing. So first of all, explain it to the audience, and then we'll talk about how it might apply to other sports.
Okay, so I almost forgot about winner and loser effects. Yeah, so winner and loser effects. It's a phenomenon that was studied a lot in animal behavior, and the idea is that all things considered equal, the difference in body size between animals, home versus away, whether one's hungry or one's just finished eating and they're fighting over food, whether it's one person's mate and they're fighting. All controlling for all that, you basically have identical competitors. If an individual is coming off of a recent victory, they're twice as likely to win the next battle, next fight, compared to an individual that's naive, coming off of a no win or no loss. An individual coming off of a recent loss is 5 times more likely to continue losing relative to a naive individual. So again, controlling for body size, all that, just the feeling, not the experience, just the feeling of that victory or the feeling of that defeat, it modifies the behavior of the individual in successive contests. And it makes sense that it should. If you just got your butt kicked, maybe you shouldn't do that again. Or, maybe you need to heal up and recover, So you should be disincentivized to want to, jump right into another contest. If you just won a contest, again, you should be more incentivized to do that again. You just got a victory. It's like reward, keep doing it. So when I made those, quoted those numbers of 2 times versus 5 times for winners versus losers, that was a meta-analysis done looking across non-human animal species, but ranging from fish to like birds and reptiles and stuff like that. So it's really this carryover phenomenon. You can really think about it as momentum or like a slump. Just really think about it like that. It tends to be governed by testosterone and other stress hormones. There might be other things involved as well, but typically the responses are governed by testosterone, where an individual that just suffers a loss is going to have a decrease in testosterone, which would make them less aggressive. An individual that just won a contest would make them have an increase in testosterone, more likely to more aggressive, and testosterone. Testosterone differences going into a fight usually predict the outcome of the fight. So you can see it's like a feedback. So but these effects they're temporary. They're only about a few hours, maybe a day. It really depends if you're measuring it the physical outcome, like in the contest, or if you're measuring it the physiological response. Those don't necessarily overlap perfectly, but they typically last about a day or so. But you can imagine that if you just say got your butt kicked, and you don't have to fight again for like another month or a couple of months, that those effects should be washed out of you by then. But not if you're constantly reminded of it. Not if every time you go on like Twitter or Instagram, you see yourself getting knocked out, you know, then you might just be like, oh. So you can imagine that that the reintroduction of it, it probably can manifest, even though the content itself might have been in the past. So,
Right.
so with regards to baseball and softball, this is also another study with Andrew Gallup. We were chatting about winner and loser effects, and he just goes, hey, you know, doesn't baseball like basically have a perfect natural experiment for this? Because in double headers, you literally play a game and then you turn around and you play again. And it's a nice control too, because you're also changing pitchers, you know, so you really are kind of measuring. I mean, if they're the same pitcher, it might be maybe a better control, but you can truly see that if you're even changing some players and you're still having this carryover phenomenon, then you really know that it is something that's just part of the feeling of that win and loss carrying on. So it was a very simple prediction. The outcome of double headers can either be swept or they could be split. You know, a team can either win both games or they can win one game and lose the other game, you know. And so it should be 50-50 of the time. If, you know, all things considered equal, they're equally matched teams, which you can control for when you control for records going into the match. So we find, especially looking at college, baseball and softball double headers, is that when you predict randomly, they should be swept about 50% of the time and split about 50% of the time. You find in college baseball double headers, over 70% of the double headers are swept, and less than 30% are split. And then for softball, about 68% of double headers are swept, and you know, actually the opposite are split. And now you might wonder, you're like, okay, what the team that's better is going to win both games, you know? But we actually winnowed down the analysis to look at teams that were within 5% of each other with win percentage. So pretty much evenly matched records going into these matches, and it did not change the outcome. There was still percentages they remained exactly the same. There was 70 point something, like I think it went from 70.6 to 70.8 males, and for females, I think it went from 67.5 to maybe 68. So it actually crept up a little bit, but it really shows that you lose that first match, you know, your body just goes, I want to go home and sleep. I don't want to go up there again, you know. And you win, you're just like, give me that person again. Just look at like a UFC fight. You could have individuals that were almost evenly matched, and then they literally don't know who won the fight until they raise someone's hand. The person whose hand gets raised, they're jumping all over the place. They look like they could fight another person right then and there. You know, and you go, what's the difference? What's the difference? You know, they both went through this grueling contest, and you say, well, one won, and the other one lost.
Yeah, this is fascinating, Tony. Now, I don't know the data. I haven't looked at it, and I think this would be a great study for Omar. But like, for instance, when Mike Tyson lost to Buster Douglas, after that, he started losing. Chuck Liddell, he was invincible until Rashad Evans knocked him out. He started losing. There's a pattern there, and I don't know if it's always the same, but it seems like when a fighter loses that aura of invincibility, it's like, well, wait a minute, he just got beat. I think I got a chance. So, Tony, comment on that, because you've worked with high-level fighters. If there's psychology going on there, or what is it?
Well, I think in the instances you're talking to, Joey, that we have people that haven't ever lost, right? And have been deemed invincible. I think there's a difference maybe amongst the athlete that goes in as a slight favored and loses, as opposed to somebody like a Tyson or somebody that's deemed invincible, then takes their first loss on the chin, particularly to an individual who didn't belong in the same cage or the same ring. You know, and to Omar's earlier point, it would seem the animal reactions in the loss are much more limbic in nature, but they don't dwell on it. I don't know. I'm assuming they don't have the capacity. They may be reminded they lost last time, but a lot of the loss is very cognitive for a human being. To Omar's earlier point, they dwell upon this. Now they see it on Instagram, even though Tyson didn't. That sense of invincibility that he lost to, I forgot the exact odds on Buster Douglas fight.
Oh, it was
crazy.
crazy.
I remember that.
I was shocked.
Right. And that has got to, if your brain, this isn't even neurobiological, you persist on, you ruminating on that, and the messaging isn't going anywhere, that's a tough road to get out of. I think the individual that has had wars their entire career is probably going to be better suited for a loss than the fighter, you're right, that has been 30-0, and at that given point didn't have a fight go beyond 6 rounds or 7 rounds. That's much more damaging, I would think, from the sports psychology or psychological perspective to the invincible than it is to the person who squeaked out those wins, who has previously lost, but is deemed very good. That's what I've seen. That sense of invincibility does go, particularly if they have an upset. I've seen this in athletes. They make the upset, and then they have 4 or 5 good runs in a row, and then they lose right after that. Boy, there's a switch that's really hard to turn back on again. Because that sense of invincibility or that streak has just been put, it really do feel invincible for a while. And they start to believe that, and they're told that.
Go on, Omar.
It's really incredible how much psychology again plays a role in most things that humans do. Because if you're losing to another human, you have to think about it, because it might not be a brute force thing why you lost. It might be a strategic thing,
Exactly.
and you got to now ruminate and outsmart and really get on it. So it really is interesting to see that psychology, but also you make an interesting point how some individuals can cope with it better than others. When we look at college baseball doubleheaders, again, they're swept at about 70%. You look at Major League Baseball doubleheaders, and they're swept about 55% of the time. So the winner and loser effect is much more diminished in the professional crowd than it is in the amateur ranks. And you might kind of wonder, there's also a larger break between the contest in Major League Baseball. They have hours as opposed to like 15 minutes for college. However, part of what makes you a professional is you can cope with losses. You can go up there and strike out swinging and look like a complete ass, and then get back up and then just forget about it right away, and then do well the next round. If you dwell on that down performance, you're not going to be a very consistent athlete, which means you're not going to get drafted. You're not going to sign a contract. You're not going to make it. So that's one thing that Andrew and I always kick back and forth when we talk about winner and loser effects is how important would this be for the, like, say, scouting department, to not just measure someone's physical attributes like their 40 time and their height and their weight, but how vulnerable are they to continuing low performances?
Exactly.
Like, how streaky are they? How susceptible are they? And can you measure that in an individual athlete? And should that be something that you consider when it comes to building a team? They always say role players play better at home. When you always hear that in the NBA. Yet stars are consistent. Why are stars consistent? Because they're consistent. That's why they're stars. And individuals that they get a testosterone surge because they're playing at home and they play better, and then when they're away, they get a testosterone loss because I'm not home and they don't play as well. That's why they're not stars. But the star athlete, they're gonna be unwavered whether they're home or away. They're just gonna they're less vulnerable to these effects. So it's really, to me, I think it's really one of these sort of not directly measured, but extremely important traits that really separate the stars from the regular athletes, but also professional athletes from the lower ranks, the amateur rank.
And one quick note on that, just to close it, it's the psychology behind it is very different in many cases in a team sport versus an individual sport. When you as the individual have lost from that pinnacle, and it's you and nobody else, and the catcher didn't call a bad game, or this guy, it just, but it's much more challenging when you were out there by yourself in taking that loss, and sometimes I think in the team environment at times.
I don't know if they've been directly measured, but you make a great
it'd be hard to measure, but yeah.
But they also they measure this in fans. So they measure this in soccer fans. So individuals watching the contest, when their team wins, they have a winner effect. They have an increase in testosterone when their team wins. When their team loses, they actually have a decrease in testosterone. And I was teasing or joking with my class about it, saying, you know, what happens after like a team wins like the World Series or something like that? Like they all get this surge of testosterone, they all have sex, and then they have a bunch of babies.
Or they burn the city down like a lot of cities do.
But when the team loses, I bet there's a decrease in pregnancies resulting in that weekend of the loss, you know. But it's funny, yeah, it can carry with you if it's a team, because or if you're just a fan of the team, if you're just a fan. But I imagine for a fighter, that's got to be the much more devastating loss fighting or something like wrestling than something like where it's a sport where you just missed like a shot or something. Someone just physically manhandling you and just making you just tap out or just knocking you out cold. That's just going to sit with you a little differently than like, oh, the ball bounced out, you know, or the ref made a bad call. Like, one of them's going to eat you at your core, you know. You're gonna look at yourself different in the mirror, you know. You're gonna look at your kids, you know, like oh, I'm a failure. So one of them's going to make you feel a lot different, obviously, than the other. So.
Well, Omar, yeah, we got to be respectful of your time. I know you have to teach, but this was a fascinating conversation.
Totally awesome.
The evolution of sports or sports performance is super cool stuff, and I'm sure our audience will love it. So thank you for your time.
Maybe a part 2, Dr. A. What do you think?
Oh yeah, I'm always down.
This stuff. Yeah, I love this stuff. In fact, I have so many follow-up questions. I mean, we could go on forever on this stuff. But
yeah, it's cool.
Yeah. Whenever you guys need another one, just pencil me right in. I'd love to jump in.
Yeah, and bring Andrew next time. We'll have to have Andrew.
Oh yeah. Oh, for sure. We definitely need Andy here.
I'll be sure to yawn for him too.
Oh yeah, for sure. We'll see how many times we can get contagious yawns all the way through.
Hey guys, hey, thank you so much.
Thanks, Omar.
And we'll catch you guys later.
Excellent. Thank you.